Hi everyone, myself Pavan here. I'm from Sri Venkateshwara College of Engineering. I belong to the section Chevrolet. I'm studying CSE stream in the second semester. Now I am going to present PPT about corrosion chemistry, which comes under the subject Applied Chemistry for CSE stream. Now, these are the topics to be covered in this presentation. The definition of corrosion, what are the process of corrosion, electrochemical reactions, anodic reactions, cathodic reactions, what are the types of corrosion, corrosion preventions means the methods of preventing corrosion, then example of corrosion in our day-to-day life, at last the conclusion. Corrosion is a natural process that converts a refined metal into more chemically stable oxide. It is the gradual elimination of metal by chemical or electrochemical reaction with their environment. Corrosion engineering is a field dedicated to controlling and preventing corrosion. When an iron metal or any metal which exposed to the corrosive environment, the part which undergoes oxidation will undergoes rusting, that part becomes rusting, and the part which undergoes reduction, it does not affect anything. Now, what is corrosion process? Corrosion is a process through which the metal's manufactured states return to their natural oxidation states. This process is reduction oxidation reaction, in which the metal is being oxidized by its surroundings, often the oxygen in air. This reaction is both spontaneous and electrochemically favored. Now, as you can see the example, the rusting of iron. The first oxidation takes place, then the reduction. See, as you can see, the iron metal is pure in the first image, and even if you look at the second image, it is rusted due to oxidation and reduction. Now, in the next image, first the steel undergoes corrosion process, then Fe2 plus becomes, then energy will be released and Fe2O3 hematite iron ore is formed, then energy added Fe, then alloying process, then back to steel. This is the process of corrosion. Electrochemical reactions. Corrosion is an electrochemical reaction. Electrochemical reaction or redox reactions are tremendously damaging to the modern society. Example, rusting of cars, rusting of taps, and rusting of so many iron, metals, etc. In anode, we can see Fe goes Fe2 plus 2 electrons, and in cathode, O2 plus 2 water molecules plus 4 electrons gives 4 hydroxide ions. In net reaction, 2 Fe solid plus oxygen gas plus 2 molecules of water gives 2 FeOH twice solid, which is solid. Now, mechanisms for minimizing corrosion. Sacrificial anodes, which is a cathodic protection. Example, manganese. Next, coatings like galvanized steel coating. Next, zinc layer formation, zinc hydroxide into zinc carbonate. Next, this is inert like Al2O3. If breaks, zinc is sacrificial. In the image, you can see the electrochemical reaction of Fe2 plus. Now, what is anodic reaction? Definition. The removal of one or more electrons from an atom, ion, or molecule. Equation M becomes Mn plus N electrons, in which M becomes an N positive charge ion and in the process loses its N valence electrons. Electron is used to symbolize an electron. Example, zinc, it becomes zinc 2 plus 2 electrons. Anode is the side at which oxidation takes place. It is the side which it gets rusted. Now, as you can see, the anodic reactions. Example, zinc becomes zinc 2 plus 2 electrons. Fe becomes Fe2 plus 2 electrons. Aluminium becomes aluminum 3 plus it releases 3 electrons. Then Fe2 plus becomes Fe3 plus it releases 3 electrons. Then H2 becomes 2H plus and 2 electrons. Then 2 molecules of water releases oxygen plus hydrogen plus electrons. Oxidation reactions produce electrons. Then Leo. Leo is losing electrons is oxidation. It is a simple word to remember this. Next, cathodic reaction. Cathodic reaction are reduction reactions which occur at the cathode. Electrons released by the anodic reactions are consumed at the cathodic surface. Unlike an anodic reaction, there is a decrease in the valence state. The most common cathodic reactions in terms of electron transfer are given below. 1. 2H plus 2 electrons gives hydrogen air in acidic solution. Next, oxygen plus 4 hydrogen ions plus 4 electron gives water in the acidic medium. Next, 2 molecules of water plus oxygen plus 4 electrons gives 4 hydroxide ions in the neutral and alkaline solutions. Then Fe3 plus electrons gives Fe2 plus metal ion reduction in the ferric salt solutions. Next, the metal decomposition. M2 plus 2 electrons gives M, Ni plus 2 electrons gives Ni, then copper 2 plus 2 electrons gives copper. Bacterial reduction of sulfate. SO4 2 minus plus 8H plus 8 electrons gives S minus plus 4 molecules of water. As you can see the diagram, it is a cathodic reaction of ferrous. First the solution, then H plus going and coming, then cathodic reaction 2H plus 2 electrons gives H2. Cathodic electrochemical reactions. These are the example of cathodic reactions. 2H plus 2 electrons gives H2 gas, then H2CO3 plus 2 electrons gives H2 gas plus 2 HCO3. Next 2 HCO3 plus 2 electrons gives H2 gas plus 2 carbonate ions. Next 2 molecules of water plus 2 electrons gives H2 plus 2 hydroxide ions. Next, these are the types of corrosions. In corrosion, it is divided into two types. One is uniform and localized. In localized, it is subdivided into two types. One is macroscopic, another one is microscopic. In macroscopic, there comes galvanic, erosion, crevice, pitting, exfoliation, de-alloying. In microscopic, it comes intergranular, stress corrosion, cracking, corrosion fatigue. And these are the images you can see. In first one, uniform corrosion, atmospheric corrosion, corrosion fatigue, next intergranular corrosion, pitting corrosion, then stress corrosion, then waterline corrosion. Then what are the preventive measures against corrosion? Organic coating. Apply on metallic surface for protection from corrosion and also to impart decorative value such as paints, enamel, varnishes and lacquers. Corrosion inhibitors. Substances which when added in a small amount in an environment reduces the rate of corrosion of metal exposed to that environment. These are two types of cathodic and anodic. Inorganic coatings are produced by chemical or electrochemical reactions at a metal surface to protect base metal from corrosion. Example, phosphates, oxides. Next, by using pure metal. Next, by using alloys. Now, these are the examples of corrosion in our day-to-day life. As you can see, the rusting of tools, then small houses, then cars, taps, etc. Conclusion. Corrosion is a natural degenerative process affecting metals, nonmetals, and even biological systems like the human body. Corrosion of engineering materials leads to significant losses. An understanding of basic principle of corrosion and their application in the design and the maintenance of engineering systems result in reducing losses considerably. Thank you. If you do like the video, please like, share and subscribe.